Alright, so I have section 4.2 on Pascal's triangle, and Blaise Pascal was born in 1623 in Clermont-Ferrand, France. He died in 1662 in Paris, France. So during his lifetime, Pascal was a mathematician, physicist, an inventor, a writer, and a Catholic theologian. And in 1642, Pascal is credited with inventing the first adding and subtracting calculator so that he could help his dad do taxes. Alright, so to make Pascal's triangle, you just simply start with the 1. And you put another ones right by the sides. And then from here, so you always have the outsides be a 1, so it's just a 1, and then from here I would add these 2. So that's a 2, 1. So then to make the next line, 1s are always on the outside. 1 plus 2 is 3, 3, 1. Then from here, another 1 on the outside, 4, 6, and 4. And so we can just continue that as long as we want. Alright, so now that we know how to make Pascal's triangle, it's important that we know how to use it. So if we were given the problem a plus b to the 4th power, that'd be an example of where we'd want to use it. If it was just a plus b squared, I'd probably just factor it out, but when it gets about to the 4th power, that's when it's most practical to use it. So if we write it out, we know our first row is 2, second row is this one, third is 1, 3, 1, you just keep adding the numbers. 1's on the outsides, 4, 6, 4. Alright, so this is the row that we would be using for this problem. So with these types of problems, you just give the exponent all to this first term, and then we just keep transferring it until this term is the only one with it. So we use this, so we just know there's a 1 out in front of it, so I'm not even going to write it. Just a to the 4th. We give all the exponent to that first one. So in the next one, this number, we use 4 a cubed b. We're just constantly transferring the exponent from the a to the b. So we look right here, we see the number we want is 6. A squared, b squared. Transferring the exponent. Again, we see the 4. A, b cubed. Then we look, just a 1, and then the b to the 4th. So we transferred the exponent from the a to the b, and that's how you know you did that problem right. Alright, so now that we kind of know what to do, the problem up there is 2x plus y to the 5th, and you guys will have 30 seconds to try to do this problem. Alright, so now that you guys have had a chance to try this one, I will show you how we do it. So as we know, we'll be using this column for it. So we know to put a 1 out in front, and then we know that times 2x to the 5th power. So 2 to the 5th, x to the 5th. And then for the next one, we will be using this coefficient, so 5 times 2 to the 4th. X to the 4th, and y to the 1st, because we're just transferring the exponent from this 2x to the y. So then from there, we will be using 10 as our next number, so that's 10 times 2 to the 3rd, let's see, 2 to the 3rd, x to the 3rd, y squared. And from there, we'll be using a 10 again, so 10, 2 squared, x squared, y to the 3rd. Next one, we use our coefficient, the 5, 5x, 2 to the 1st power, x to the 1st power, and then y to the 4th. And we know we've done this right if this is the only one which has power, and it is y to the 5th. So from there we just have to simplify and we'll get our answer. So 2 to the 5th, that gives us 32 x to the 5th. You simplify this, 2 to the 4th times 5, that gives us 80 x to the 4th y. And so this one, 2 cubed times 10, that would give us 80 again. 80 x cubed y squared. 2 squared times 10, that gives us 40 x squared y cubed. 5 times 2 to the 1st, that's just 10 x y to the 4th. And then from there, if we've done it right, we know that the last number has the entire exponent, which it does. So that's how you would solve that one. Alright, so now in 4.2, they do have problems within Pascal's triangle where you need to use negative signs. And so they're saying things positives, you just have to keep in mind the exponents that they're using. So if you write it all out, you get this equation. From here, you just need to simplify. So obviously, x to the 4th. Here, since this is a -3, that would end up being negative 12 x cubed y. And so now this one, because it's squared, the 3 will be positive. So it is a plus 54 x squared y squared. So now this one, because it is cubed, if it's an odd number, it keeps its sign. So that would be minus 108 x y cubed. And here, it's positive, so it becomes positive. Plus, I already wrote that, 81 y to the 4th. Alright, so also in 4.2, they want us to learn how to add and subtract polynomials. So if I have the equation 3x cubed plus 2x squared minus x minus 7, all that plus x cubed minus 10x squared plus 8. Alright, so then the easiest way to do this would to be just to rewrite it and put one under the other so we can just add downwards. So I'm going to rewrite it a little bigger. 3x cubed plus 2x squared minus x minus 7. And so then just right under that, I'd line it up with the exponent it would have. So x cubed, go under there, minus 10x squared, we're going under x squared. And so now we don't have an x in this portion, so I would just say plus 0 and then plus 8. And all of this is being added. So this would obviously just be 4x cubed. This one would be minus 8x squared. That's still minus x. And then 8 minus 7 is 1. So that's how you do those types of problems. Alright, so you can probably assume that if they're going to make us know how to add them, we're going to have to learn how to subtract them. So it's basically the same thing, not very difficult. So we just write it out on top of each other. Think about it logically. 3x cubed plus 7x squared minus x plus 4. So again, you just line the exponents up with that one. So you just for the negative sign, you just distribute it to all this. So we know that that's a negative 2x cubed. And that's a positive 3x squared. We know that there's nothing right here. So that's just, we can even just say plus 0. So it's just nothing. And then so negative and minus 8. So from there, you just subtract down. So you end up getting x cubed plus 10x squared minus x minus 4. very similar to adding. You just got to distribute the negatives.